हेलो।
तो
यस सर। आज क्लास है ना?
और क्या।
तो आया तुम्हें?
आ रहे हैं सब, धीरे धीरे आते हैं। हम्म लास्ट क्लास में हम लोगों ने ये किया था ना, कंजर्वेटिव एंड नॉन कंजर्वेटिव फोर्सेस। अच्छा, अब मैं तुम्हें बताता हूँ। नाउ आई विल बी टेलिंग यू अबाउट द वर्क एनर्जी थ्योरम। सी व्हाट इज द बेसिक कॉन्सेप्ट ऑफ वर्क एनर्जी थ्योरम। अच्छा, एक और चीज, वन मोर थिंग। हरिप्रिया, टुडे मॉर्निंग आई हैव टॉक्ड टू योर मॉम। यस, यस हरिप्रिया।
Yes, sir.
And while I was talking, he said, "You did not buy that book till now. That book, the previous year question book,
Yes, sir.
MTG. That buy that book. See these questions that I am giving now. Those questions that as a worksheet, mains and advanced, they are not sufficient. Your means they are just for practice only. Your ultimate aim is to solve the questions of JEE main and advanced previous year questions, because then only you will come to know that you are on the right track. Means you are able to solve the actual questions that has been asked in your examination. Okay, it's customary. What I suggest to every student, same thing I have told to Radhika also, same thing I have told to Kanishka also and Shyama also, that what you have to do is you buy that book. After the chapter is over, try solving the JEE main previous year questions from the book that I have given. If you find difficulty in solving those questions, leave that. Try solving easier questions, that the easy level questions that I have given in the PDF. Easy question, then move on to the advanced question. Then after easy questions, you will be able to attempt those previous year questions. Either way, you solve the easy question, then advanced level question in the PDF that I have provided, then move on to the JEE main question, JEE main previous year question, because your ultimate aim is to solve the JEE main previous year questions that has been asked, because then only you will come to know that I am okay with the chapter. Then only you should finish the practice of that chapter. Getting my point?
Okay, sir.
See, you have solved the questions that I have given you. Then after completing the question, you will get an idea that a sir has given me the question. I am able to solve those questions, so I will be able to solve every kind of question now. But when by chance you attempt the previous year questions of JEE main that has been asked in your JEE main examination, there you are finding difficulty. That means you need to practice more. Okay, na?
Yes, sir.
That's the thing. For every examination, this should be your practice, because it's needed also for the board examinations. Also, if you are writing the board examination next year, you write. For that also, you have to buy one previous year question book, and time to time after the chapter is over, after you're done practicing some question from your chapters, then try to attempt the previous year question. If you are able to solve previous year question very easily, then only you think that, okay, now I'm done with this chapter, I should move on to the next one. But see,
Okay, sir.
what the problem arises here, problem also I'll tell you. The problem is when you will be solving the questions now, you won't be able to finish those questions because there are so many questions. So if you target completing all the questions, you won't be able to. Means you will be able to solve 30 or 40 questions at once in 2 or 3 days of previous year JEE Main previous year questions, or then it will get boring. And during that time, I will start some other chapter, other physics chapter. So you will focus on solving those questions. So what the thing is, whenever you are solving the questions, it means I am teaching you, and then you are solving the questions of previous year question, you keep on solving them. Just you have finished 40 questions, then you have moved on to the other topic, then come back again. You have solved 40 questions of another topic, come back again to the first one, try solving the remaining questions. So like that, you have to finish the questions. JEE Mains previous year question. Then only you will feel confident that you are able to solve, because then if they give you question in the examination hall, you will be able to do it. Okay, like that.
Okay, sir.
Solving previous year question is necessary, it's must. Acha. Now let's move on to the work power energy. Work energy theorem. What is work energy theorem? Work energy theorem states that work done, W total, means total work done, is equal to change in kinetic energy. What is kinetic energy? Kinetic energy is equal to half into m into v square, that you know. Then suppose I'll give you an example. The statement is W total work done is equal to change in kinetic energy final minus kinetic energy initial. Achha, Kanishka, same thing to you also. For everyone I'm telling you, don't get carried away by solving your module questions. Radhika, तुम्हें भी बोल रहा हूँ मैं. If you are, suppose if you are solving some module question like some institute like Narayana or your Akash or physics wala, or some module you are solving, and after solving you are feeling confident that I have solved these questions, then I will be able to solve the questions of JEE Main also. Wrong practice. It's not necessary to solve your module questions, but it is very much necessary to solve previous year question. That's must. If you are neglecting them, you are doing mistake. You will score lower in your examination, final exam. It's guarantee. Okay, this is your W total is equal to kinetic energy minus kinetic energy initial. Now let me explain this. Suppose a body is there. Now I have applied some force on it. Some force I have applied here, this force. And due to this force, it has done some displacement. This angle theta. Now initially they say, initially this body, this mass m is having an initial velocity of v1. And finally, due to this force and displacement, when it comes here, it has got the velocity v2. This force is continuously acting. Force should be acting continuously in the same direction. It's not variable. If it is variable, then in that case, you have to integrate it and find out the work done. Okay. This force is constant. So here, throughout this displacement, the W total work done will be what? F cos theta into x. This is work done. This will be equal to change in kinetic energy. According to work energy theorem, it will be half m into v2 square minus half m into v1 square. This is F cos theta into x. This is how we do it. Easy? Understood? So this is your statement of work energy theorem. Now let me give you some easy question on this. Then I'll give you tougher one. Do you know something about momentum? Radhika?
जैसे like डिटेल में नहीं करता.
मोमेंटम मास इनटू वेलोसिटी होता है ना भैया. अच्छा, try to solve this question. Very easy. Easy questions you are able to solve very quickly. I'll give you some one question in which some thinking will be. I think here the work energy theorem is not acting. You need not have to do using work energy theorem.
So, will the force acted on the body equal to 40 Newton?
Correct. Very good. What about others?
The integer type है.
Integer type है. Haripriya, did you get the answer?
And minutes.
ओके, कनिष्का तुम बताओ आंसर क्या है तुम्हारा. ये राधिका तुमने क्या बोला था अभी?
40
40.
40
हाँ
Newton.
ठीक है ठीक है.
40.
40 ना? कनिष्का तुम्हारा आया?
Yes, sir.
कुछ नहीं करना है, बस इजीली सॉल्व करना था। ऐसे करके देखो, एक्वायर्स द काइनेटिक एनर्जी ऑफ दिस, मतलब हाफ एम, इसमें कुछ भी नहीं करना था। हाफ एम वी स्क्वायर इज इक्वल टू 10,000। तो इससे मास पता है तुम्हें, मास 2 है, तो वेलोसिटी निकल जाएगी। v इज इक्वल टू 100 फोर्स एक्टेड अपॉन द बॉडीज। अब v तुम्हें पता ही है, एट द एंड ऑफ फिफ्थ सेकेंड। तो v इज इक्वल टू u प्लस, u तो जीरो था, u was zero, so 0 plus इसका acceleration that you have to find into time is the 5 second. So acceleration will be equal to 100 divided by 5, so it will be 20.
You could use the direct formula.
Which direct formula?
You could have used half AT square.
Half 80 square. But for that we have to find out the displacement. Oh ho, acha acha acha, हाँ, very good, very good, very good. That's another way of solving the same question. I'll show that also. 2 into 20 is equal to 40 Newton. राधिका तुमने कैसे किया, इससे या
ऐसे
उससे?
करा,
ऐसे?
इससे
हाँ,
आसान से ही लग रहा था, वो फॉर्मूला बड़ा लग रहा था।
नहीं, see how Haripriya has done. It's the different method. Very good, Haripriya. The work done, W total, is equal to change in kinetic energy, which is half mv square. W total is force into displacement. Displacement she has written half into a into t square, which will be half into 2 into v square, which is actually you need not have to do something here. 10,000 f into half into. But Haripriya, again you have to find a na here.
So you found A over there, so method 1.
In the method 1, we have found out the a using v is equal to u plus 80. Then again using force F is equal to ma, I have found out the force.
You could write F as MA square. You could write it as MA square is equal to 10.
That only I was asking, because I know F is equal to ma will put, but how did you do it? Ma square is
I
okay
can.
then. Okay, then it's okay. 2 into half into a square it will become, because F is equal to ma will put, into 5 square will be equal to your 10 power 4. So this is this. So a into 5 will be equal to 10 power 2. A is equal to 20. That's another way of doing the same problem. So the force will be equal to mass into acceleration, that is 2 into 20. Either way you can solve it. This is using work energy theorem. That is without using work energy theorem. Now did you see this one?
Yes, sir. So in which we have completed up to work energy theorem, sir. Like same.
Acha, in the class, in your school?
Yes, sir.
Okay. And it's okay. So try solving this question. So what they have covered? Means work energy theorem, basic statement they have done.
So they finished work, variable work.
Huh?
They gave some advanced problems like that hemisphere wala question and all.
Acha.
And then they moved on to power. Power didn't take that much of time. Energy, potential energy is then spring mechanical law of conservation of energy. Currently, we are doing problems based on it. I guess we are almost done.
The law of conservation of energy they told you.
That is
Oh.
law of conservation of energy is different. Law of conservation of mechanical energy only we are mainly doing.
That is only law of conservation of energy. After this, I was planning to do that one only. Try solving this.
So, do we also need to find out impulse in this question?
The body moving momentum of this force acting on body. Is it needed?
Not yet. It's there.
Impulse is needed. Then only you will be able to find the momentum. Impulse momentum is there.
So can you remind me the formula?
Acha, let me tell you about impulse. Acha, don't solve this question now. Let me tell you something about impulse. What an impulse is. See, impulse is force acting for a very short duration of time. It's like jerk. Means it's like that now. Means you just push it. You just push someone for very short duration of time. You are not constantly applying the force. So how they say, when a force is acting on a body for a very short duration of time, suppose delta t, this delta t is equal to change in momentum. F into delta t, this is impulse, and this impulse is equal to before this impulse was applied, this force was applied, its velocity was u. After this impulse, its velocity became v. Then in that case, we can write mv minus m into u. This is how they say f dot delta t mv minus. But you should question, why did we get this one? Why do we get this only? Impulse is equal to change in momentum. This is because of your basic definition, F is equal to ma. A is what? dv by dt. Now m into dt will be equal to mdv. Sorry, what I have written? I don't know what I have written. This is F into dt. This F into dt is supposed to be impulse. So this impulse is equal to mdv, meaning difference of velocity m into v minus u. That's why this equation arises. Actually, this thing that we have learned is not new. It's nothing new. The only thing that is new to you is impulse is nothing but a force which is acting for a very short duration of time. Right? Clear? Haripriya, Kanishka, Shama, Radhika, everything clear to you?
Yes.
Yes, sir.
Now after this only comes your conservation of momentum. When I'm saying about this one, let me tell you about conservation of momentum also. Now this should be new to you, na? This you must not have learned.
No, sir.
Because see, the question I have given now, this is a mix of that work energy theorem and conservation of this momentum. Because actually, whenever they will be asking you good quantity live question, means this is from JEE main. Whenever they will be giving you good questions, they will be mixing the concepts of conservation of momentum like collision or the momentum one, impulse momentum and work energy theorem. That's very common. Now coming to conservation of momentum. Now cases arises sometimes when a body is there, the body is moving, his body is moving, and now you consider the case that no force has applied. Somehow it changed its velocity. Don't know how. Somehow it changed. In that case, when force is not there, then impulse will not be there because F into delta v t will be equal to 0. Okay. So then here impulse will not be acting Conservative forces we do not take. Conservative forces, like conservative means mg and all. Mg forces, no kind of force is acting in the horizontal direction. This momentum is mass into velocity. Velocity is there, so it is directional one. Momentum impulse is also directional. So we are considering in this direction. In this direction, no force is acting. Vertical direction forces can act, like mg can act. So we are not concerned with the mg. In the horizontal direction, since no force is acting, it has changed its velocity. So impulse is 0. That means 0 is equal to mv minus mu. That means final momentum will be equal to initial momentum. This you should know. Momentum is m into v vector. That's why whenever there is no force, no external force, means momentum is conserved. Okay. Final momentum is equal to initial momentum will be there. Understood this point? Me, Haripriya, Radhika, Shyama, Kanishka, you have understood this one, what I am saying?
Yes.
Okay. Now
Yes,
see,
sir.
now there is a very peculiar case in this. Sometimes there are two bodies, one body, another body. They were moving very happily. This was moving like this. This was moving with certain other velocity. And it can be, they have said u1 was greater than u2. Now at one point, what will happen? They will collide with each other. They teach this part during collision, but I am teaching you here because it's needed. Because whenever you will be solving the questions now, you will need it more frequently. They collide here, and then after collision, what they did, this is collision, this is m1, this is m2, and after the collision, they started to move with different velocities. One is this, another is this. This is v1. We do not know what is v1 and what is v2. Now here in this case also, momentum will be conserved. Why? Because the only point where the forces are acting is at the point of collision. This m1 and m2, they are colliding with each other. So during the collision, this m2 is applying a force here, and for a very short duration of time when the collision was there, and m1 is applying equal and opposite force on m2 because of contact force. So when we take m1 and m2 as system, in this system, only one force were acting, means the kind of forces were acting only during the time period when they were in contact, they were colliding, and the net force is 0 because they are cancelling. They are contact force, they are equal and opposite. When we take the system of m1 and m2, both the masses, the net force is 0. That means what is happening? That net force has become 0. So F net in this direction is 0. That means net impulse will be 0. So conservation of momentum holds. So we can write initial momentum m1 u1 plus m2 u2 will be equal to final momentum m1 v1 plus m2 v2. Understood?
Yes.
Now this is conservation of momentum, that is impulse. Now you can try to solve this question. but I think you can solve this question without using impulse momentum concept also.
Sir, what should be the answer?
30 joule. ठीक है, इस क्वेश्चन को तुम बिना इम्पल्स वाले कॉन्सेप्ट को यूज करे भी सॉल्व कर सकते
Okay.
हो। मैंने अभी देख लिया करके, हो जाएगा।
तो 32 ला रहा है,
कितना है? 20।
30 जूल।
हाँ सही आ रहा है।
मैंने इम्पल्स वाला कंसेप्ट यूज करके किया है, कि बिना कैसे करना एक बार आप बता सकते।
एक बार देख लेते हैं। श्यामा नीड टू गेट द आंसर। श्यामा और हरिप्रिया और कनिष्का। श्यामा, could you solve this one? I think he has not solved. देखो राधिका, विदाउट इम्पल्स वाले मेथड से हम ऐसे करते हैं। बॉडी ऑफ मास इज मूविंग इन मोमेंटम ऑफ 10 kg/m/s। मतलब इनिशियली ये जो बॉडी मूव कर रही है ना, इसका मास 5 है और इसका मोमेंटम है, मतलब m इंटू यू, ये है 10। तो m इंटू यू इज इक्वल टू 10, यानी कि 5 इंटू यू इज इक्वल टू 10, यानी कि इसकी इनिशियल वेलोसिटी 2 मीटर पर सेकेंड है। ठीक है, now a body a force of 2 Newton acts for the body in the direction of 5 seconds। 5 न्यूटन फोर्स लग रही है, दिया हुआ है फॉर दैट 5 सेकेंड। अब क्योंकि फोर्स लग रही है तो इस पे एक्सेलरेशन भी आएगा, कांस्टेंट फोर्स है ना। F is equal to 5 into acceleration, acceleration will be 1। now during that time it will do the displacement of x is equal to ut plus half at square, यानी कि 2 into 5 plus half into 1 into 5 square, 10 plus 25/2, 45/2। Increase in the kinetic energy they are asking. So increase in the kinetic energy will be force into displacement, work done will be work energy theorem is equal to increase in the kinetic energy delta K. So force was 5 Newton, displacement is 45/2. I'm getting different answer. अरे यार बता भी नहीं रहा है कोई. No one is telling me that I have taken wrong force. It's 2 Newton. So A will be equal to 2 by 5. Something sir okay ना? हाँ. X will be equal to 5 into 2. Velocity is same ना? Plus 5, 15. So F into 15. Force into displacement. Again I have done mistake here. F I have taken 5. F is actually 2 Newton. It's given in the question. I don't know why I have taken 5. 2 into 15. So change in kinetic energy will be 30. राधिका समझ में आया? There is method 2 also using the impulse one. That also let me do it. Impulse is force into delta t, 2 into 5 seconds. So it will be 10. This is equal to change in momentum mv minus mu. This is actually quite easy one. 10 is equal to mv minus 5 into initial velocity is 2 that you have found. Using this only you have to do it. They have given actually momentum, initial momentum. So nothing to do the calculation. You can just put the values. Mu is equal to 10. So mv is equal to 20. And you have to find out the final change in kinetic energy. So delta K will be equal to, see, if will be half mv square, which is minus half mu square. You can also write this as mv whole square by 2m minus mu whole square by 2m. So 1 by 2m into mv is 20, 20 square minus mu square is 10. So mass is what? Mass is 5. 400 minus 100. So 1 by 10 into 300. 30. This is your method 2. What happened? Everyone is silent.
Understood, sir.
What about others? Shama,
Sir, I had gotten 20, sir.
you got your mistake. You identified your mistake.
X, I considered X as.
Same kind of mistake that I was doing. You solved using the first method or the second one?
The first.
Did you see how I solved the second one using the second method?
Yes.
Shama, did you see? I think Shama is logged in the class and then is roaming somewhere.
No, that's fine.
Did you see the method too?
Yes, sir. Change
Hmm.
in kinetic energy. That's it.
It's impulse one. I have started using the impulse method.
Yes, yes.
Hmm. Achha, now see, now we'll move on to the next part, which is conservation of energy. Why do we conserve the energy? See, whenever we are applying this work energy theorem says W total is equal to kinetic energy final minus kinetic energy initial. Okay, but here this I can actually, because I have only two kinds of forces. One force is conservative force and the other force is non-conservative force. So I can just write the total work done as work conservative plus work non-conservative. So kinetic energy final minus kinetic energy initial. Now let me tell you something about the conservative force, because you know about conservative force. Whenever a body, suppose this is your mass m, this was initially at height h1. Now finally it has moved on to the height h2, this point. Can you tell me what is the work done by mg in this particular case? Tell me quickly. It's an easy one. When a body of mass m, because mg is a conservative force, when it's just a simple force into displacement calculation you have to do. It has
H2
been
minus H1 into.
h2 minus h1 into mg.
Yes, sir.
But what is the sign? Shouldn't the sign be negative?
Negative.
See, because you have moved from A to B, the displacement is up, force is down, so the work done by conservative work done will be Wmg will be minus mg into h2 minus h1. Means the work done has become mg h1 minus mg h2. This is work done by conservative force. The conservative forces will be different forces also, like spring force is also a conservative kind of force. That also we will include later, but I'm just telling you the example that when we take one conservative force, it will be mgh1 plus minus mgh2, and that is potential energy. Whenever a body of mass m is placed at a height h above the surface of earth, its potential energy is mgh. This you should be knowing from your lower classes. Okay, na? Now here work done by conservative force is mgh1 minus mgh2 plus work done by non-conservative force we do not know. This will be equal to kinetic energy final minus kinetic energy initial. Now this mgh1 is its initial potential energy when it was at A, initial point. Potential energy at initial point. mgh2 is potential energy at final point. So I can write this formula as kinetic energy final minus kinetic energy initial. I'll take this potential energy to the right side. So work done by non-conservative force becomes kinetic energy final plus potential energy final minus kinetic energy initial plus potential energy initial bracket. Understood? Now this becomes a statement. When earlier you had total work done, either take it conservative and non-conservative both, is equal to change in kinetic energy. Now you have converted this formula to further easier one. Work done by non-conservative forces will be equal to change in the mechanical energy, which is mechanical energy is the kinetic energy and potential energy sum. Now suppose there is a case that there is no conservative force. Non-conservative forces are not acting. There is no non-conservative force which is acting on the body. That means in that particular case, work done by non-conservative force will be equal to 0. In that case, we can do kinetic energy final plus potential energy final minus kinetic energy initial plus potential energy initial. So that will become equal to kinetic energy final plus potential energy final will be equal to your kinetic energy initial plus potential energy initial. This is known as law of conservation of energy.
So isn't potential energy plus kinetic energy known as mechanical energy?
Yes, mechanical energy. So you can write this also like mechanical energy final is equal to mechanical energy initial. The concept is whenever on the body there is no external forces acting, like no non-conservative forces acting, then in that particular case the total final total energy will be equal to the initial total energy which was out there for the body. This is known as the law of conservation of energy. I think this is clear to everyone.
Yes.
Okay. Acha. Now, can you solve a question on the basis of this? Let me give you one. Try solving this. Are you able to understand what this question is saying?
So the velocity at the top and the bottom are different, right?
Yes.
The negative of 245 joules? Negative में आ रहा है.
Correct. Very good. Very good. Tell me, Haripriya, are you getting the answer?
Oh, sir.
No. See, what the concept is, na? Closed circular tube of average radius 15 centimeter. This is the radius is given. Whose inner walls are rough is kept in vertical plane. A block of mass is just fit inside. Speed of the block is 22 meter per second here, where it is at top. After completing 5 oscillations, the block stops at the bottom region of the tube. After 5 oscillations. Now here, it completes one oscillation, then again it moves to the second oscillation. See, when it is moving down, what is work done by total, W total is equal to kinetic energy final minus kinetic energy initial. Okay. Now, when it has moved one oscillation, work done by mg will be 0 because mg has come here. It has completed 5 oscillations. So after 5 oscillations, total work done by mg is still 0. But after, they have said after 5 oscillation, it has come to the bottommost position. Finally, that means here the work done by mg will be equal to what? Mg into the total distance, which is twice of radius. Mg into 2r, so it is 2 mgr, which is 2 into 1 into 10 into radius is what? 0.15 meter. Okay, so it will be 1.5, it will be 3. But it is positive also. Now initial friction we do not know. The work done by the tube on the block is by the friction only, but we do not know. W work done by mg is 3, so work done by friction or work done by tube will be equal to final kinetic energy, which is 0 because it has come to rest, so final velocity is 0, minus initial kinetic energy is half into its mass into 22 whole square. So plus 3 plus work done, sorry, what m work done by tube will be equal to minus 22 square by 2. So the work done by the tube will be minus 22 into 22 by 2 minus 3. So it will be 11 into 22. Okay, now?
Yes.
it should come to, this is minus 242, I think. 22, 22,
minus 242
242 minus 3. So it will be minus
minus
245
245 joules.
joule. This is the work done by the tube. Understood? This is pure example of work energy theorem and work done by mg. Understood? Let's end it now.
Sure.
Bye bye.